Hello students, welcome to Sources classes, and this is ISI MTECH CRS paper solution we are doing right now. This is mostly keeping in mind the upcoming examination. I'll be solving some questions from the group B segment for the non-computer science part. Okay. Now, in this question, the NC means non-computer. Okay. So the first question is, let A and B a decreasing sequence, okay, and such that summation of n equal to 1 to infinity is n is convergent. So as a decreasing sequence gets to this kind of convergency, so we need to prove that the sequence of n into n goes to 0 as n tends to infinity. Quite a subjective type of question. So here let me insert a page. Okay. So now in this case, how we are thinking about a structure. Let an AN be a decreasing sequence. In general, a decreasing sequence is marked by wherever this is 1 by n. So, or if it is n by n square. Obviously it is 1 by n again, but obviously if it is n plus 1 and n square plus 3, in that way you can also see that. So the denominator's power is higher than numerator. So this is normal pattern based idea. Okay. Now, if we see that an is a decreasing sequence and Sn equal to summation of an, so which is a convergent structure. So by the Cauchy condensation test, we can say that this summation of 2n of a 2 to the power n also converges as summation of an is convergent. So in the basically the structure will also ultimately goes like a to n tends to 0. So now for these kind of structures where 2 to the power n less than k less than 2 to the power n plus 1. So what you can do is, it is 2 to the power n, a 2 to the power n plus 1, we can multiply k into ak and 2 to the power n plus 1, a 2 to the power n. So which implies that n of an tends to 0. So under this particular structure, we can see, now getting back to the question, that this particular sequence goes to 0 if n tends to infinity. Now, the next question is, consider n into n a matrix where A equal to this, In equal to identity matrix of nth order alpha and alpha t, where In is the identity matrix and alpha is n into 1 column vector, such that alpha to the power t into alpha equal to 1. So we need to prove that a square equal to a. So under these circumstances, we insert a page. Let's decide the paper background. Okay. So now in this case, A is nothing but In minus alpha alpha t with respect to the vector structure. So A square here will be alpha t this square. Under these circumstances, In square In, so I'm just splitting it, t into In alpha t whole square. So obviously it is In alpha alpha t minus alpha alpha t and In, and obviously in this part it will be the normal square goes on. So obviously into this part, this will be calculated and alpha alpha t square. So finally 2 alpha t plus alpha alpha t square. If we reach till this part, please allow me to change the color. Okay, let's go for black. So now this alpha alpha t part, this is nothing but alpha t alpha into alpha t, this thing. So if I change the positioning here, so which is nothing but alpha t here. So finally a square equal to in 2 alpha into alpha t plus alpha alpha t, so which is nothing but giving us in minus alpha alpha t, which is again giving us n, hence it is proved. Okay, now we can go to the next question. Here they are talking about A and B are two. Remember that these are like smaller proofs, not like the math or MSQMS type bigger proofs. So A and B are two invertible real matrices in order n, so that the determinant of xa plus 1 minus xb has finite many solutions. So solution based structures are very common here. So here in 3's answer we can say, so that the determinant equal to x into a plus 1 minus x into b. This is the thing. So determinant of a not equal to 0, and determinant of b is also not equal to 0. So you can observe that fx equal to determinant of xa plus 1 minus x into b. So here f of 1 not equal to 0 and f of 0 also not equal to 0. So polynomial is not identically given. So the polynomial is not identically 0. Not identically 0. So under these circumstances, since it is a nth degree polynomial, so n roots are there. So total roots are, from this we can say n, and it's a finite value. So hence the proof directly follows from the given structure.